Hello my friends and welcome to this new tutorial where we're gonna finally get our A3C agent for real by initializing the A3C agent, meaning by creating an instance of this class that we just made, the agent class. Alright, so after this huge tutorial implementing the step method, well, it will be time for us to breathe now because indeed this tutorial will be super short and easy, right? We just have to call the agent class in order to create our A3C agent object, which will represent the A3C agent itself, but without its brain trained. Alright, but of course, in a few steps, we will be training that brain to be able to fight Kung Fu. But before, let's get our AI and therefore let's create a new code cell. And here we go. As usual, we're going to call our agent and it will be created as an instance of the agent class, which takes, remember, as input only one argument, which is of course the action size, right? If we look at our init constructor method again, indeed it takes just one argument, which is the action size, and the action size of course is nothing else than the number of actions variables we got here, which is indeed 14. Okay, so here we go. That's the only thing we have to do in this agent class in order to create our agent object. So let's enter our number actions parameter, and there we go, my friends. Now we have our AI. Well, actually, we have to run the cell, and there we go. Now we have our AI. Perfect. So basically, now we have some eyes, we have a brain, we have a critic sense. Well, a critic sense that will be used during the training to basically learn better how to fight Kung Fu, and that will happen in the next tutorials. And speaking of which, our next tutorial now will be to evaluate our A3C agents on a single episode, and we will do that through a function, which we'll define in that next tutorial. So, as soon as you're ready, well, join me in that next tutorial to implement this function, and then we'll get soon to the training. And until then, enjoy AI! Hello my friends and welcome to this new step of our A3C implementation. In the previous step we finally got our agent, meaning the A3C AI for real, by creating an instance of the agent class, and now we're about to implement a new function which will evaluate our A3C agent on a certain number of episodes. Not just one episode, it will be good to have the number of episodes on which we evaluate our A3C agent as a hyperparameter. So I'm adding this into the function, and so there we go. Let's create a new code cell to define that function, which we're going to call very simply evaluate, and which will take as input three arguments. The first one is our agent, which will be of course our agent object when we call the evaluate function. Then it will be the environment, so of course it's going to be the Kung Fu Master environment, but feel absolutely free to plug our A3C agent on another environment and see how it does, right? There are plenty of other environments that you can try, especially in the A3C section. So env, and then of course the third argument will be that certain number of episodes over which we want to evaluate our A3C agent. And let's call that simply n episodes. Okay, and we're going to set the default value to 1, in case we don't specify that number of episodes value when we call the evaluate function. Perfect. So now colon, and here we go. Let's define what this evaluate function has to do. So, good question actually. What does it have to do exactly? What is it supposed to return? Well, it's supposed to return a list of the total rewards in each of these number of episodes, okay? Therefore, the first thing we're going to do here is introduce a new local variable which we're going to call episodes_rewards, and which we will initialize as an empty list, okay? And it will contain the different total accumulated rewards for each of the episodes on which we evaluate our agent. Great. Now, next step. What is, according to you, the next step? Well, naturally, it's going to be to do a for loop on that certain number of episodes. And so there we go. We start with a new for loop here. And then because we won't use the loop variable, well, we can disregard this with an underscore. And then we're going to do that for loop in the range from 0, the first episode index, up to the number of episodes. All right? So basically, it will loop over the different episodes indexes. Okay, so here we go. Now let's start this for loop. According to you, what is the first thing we need to do in this for loop? Well, right now we have to understand that we're dealing with a certain episode. Right now, the first episode of index 0. And so again, naturally, the first thing we have to do, because we're starting a new episode, is to initialize the state. And to do so, we're going to use a certain function from our environment object, which is of course the reset method. Okay, so let's do this. This reset method actually returns the state, which is of course the initialized state, but also some other elements which we're going to disregard again with an underscore. Okay, perfect, and there we go. Now we call first our environment object, from which we call the reset method. And perfect, now we have our initialized state. Now, next step, what according to you is the next step? Well, remember what we want to do. We want to get the total accumulated reward over each episode. And so now, since we're dealing with a certain episode, well, what we actually need to do is to create a new local variable that will compute that total reward. And that's exactly what we're going to do. We're going to call that new local variable of the total reward, well, total underscore reward. Okay? Which we're going to initialize, of course, as 0. Perfect. And now, again, according to you, what is the next step? Well, it is to start a new loop. But will it be a new for loop that would, for example, loop over the different time steps? Well, we have simpler actually. We can do an infinite loop thanks to a while loop, which we will break if the episode is done. Because we will have that done variable thanks to our environment object, which will allow us to break that infinite while loop if the episode is done. So let's do this. Let's do this infinite while loop, which we can do very simply with a while true. Then colon, and there we go. Now we start that infinite while loop. And so now, what is the first thing we have to do in this new while loop? Well, right now we're dealing with a certain episode, but more specifically a certain time step. And so basically what we must think is, what is the agent supposed to do in this particular time step, this first time step? Well, of course, it is supposed to play an action, because right now it is in this certain initialized state, and it needs to reach the next state, and in order to reach that next state, it needs to play the action. Alright, so let's do this. How we're gonna make our agent play that action? Well, of course, with one of its methods we implemented in the agent class, which is of course the act method. And since the act method returns the action, well, we're gonna start by introducing this new local variable, which we're gonna call action, of course, and which will be what returns that act method called from our agent. So there we go. Let's call our agent first, from which we call the act method, which takes as input, of course, the state, which right now is the initialized state, but then in the next steps of that while loop, it will be the next state and the state after that, etc. Okay, so great. Now the action is played, we reach the next state, and therefore, well, let's get that next state and also the reward that comes with that next state. So here we go. How can we get those? How can we get the next state, the reward, and also the done boolean telling us whether or not the environment is done? Well, that's of course with another function or method of the env object, which is of course the step method. Alright, so let's do this. That step method actually returns the state, which is actually the next state that the agent reaches after playing that certain action. So here we go. That's the next state. Then we also get the reward, and then we get whether the environment is done or not. But then that's not over. We also get some info, some extra info, which we won't use, but let's put that in the info local variable. And then some other elements, which we can disregard with an underscore again. Perfect. And now, time to call this step method from our environment object. So there we go. We call first our environment object, from which we call that step method. The step method, which will take as input, what exactly? Well, that action that was just played by our agent. Alright, but more specifically, we will have to take a certain index of that action, because action is actually a numpy array here. And assuming that we're evaluating the agent in a non-batch mode, well, we need to add this index 0, which I'm putting in a square brackets. Perfect, so now we get that next state, we get the reward, we get whether or not the episode is done. And so what is the next step? Remember what we have to do here to compute the accumulated reward. Well, since we have the reward, we can exactly do that. We can update our total reward variable by adding to it the reward we just got in this new step of the environment. So there we go. Let's do it efficiently. Let's call our total reward variable, and then let's do the classic plus equals to add the reward we just got here. Reward, great. And so now, what do you think we have to do? Let me actually scroll down a little bit. We got our total reward, we got what we wanted, so what do we need to do in order to exit that infinite while loop when we have to? Well, with a break, of course, which we can act on thanks to our done boolean. And so what we're going to do now is a simple if done to check if we're done with the episode, in which case we will, of course, break that infinite while loop. And if not, if we're not done with the episode, well, we will go back to that while loop and start a new time step, playing a new action, then reaching a new state, getting a new reward, adding that new reward to the total reward, and we do that again until the episode is done. And once the episode is done, what do? Well, we need, of course, to exit that while loop and go back into the for loop because we're done with the episode, but however, we still need to append that total reward we got here into our episode rewards list of total rewards on this certain number of episodes. Okay, and that's exactly the last thing we have to do here. We need to take our episode rewards list. So I'm copying it here and then still inside the for loop. Let's be very careful with that. We're going to paste it. And then of course, we're going to use the append function to add that total reward variable. And perfect. Now finally, we have the different total accumulated rewards for each of these episodes on which we're evaluating our A3C agent. Perfect. And so now, what is according to you the very final step we have to do? So first we have to exit that for loop. We're done with that for loop. Well, remember what this evaluate function is supposed to do? Well, it is supposed to return that list of different accumulated rewards on these certain number of episodes. And therefore, we're going to finish this evaluate function with a simple return, which will return, of course, I think I still have it copied, the episode, there we go, rewards variable. And perfect, we're done with this evaluate function, so let's run the cell, and there we go, my friends, we're now ready to finally implement that last feature of the A3C model. I'm talking, of course, about the asynchronous feature. Indeed, in the next tutorial, we will be testing multiple agents on multiple environments at the same time. And so please get some good energy for that. It will not be super short or super simple, if you know what I mean. So get some good energy, get a good nap or a good coffee. And as soon as you're ready, well, let's smash this in the next tutorial. And until then, enjoy AI. Hello my friends and welcome to this very exciting new step of the A3C implementation. It's a very exciting step because indeed you know that by now we have implemented the advantage in the A3C asynchronous advantage actor critic model. We also implemented the critic part thanks to that critic loss that is part of the total loss that is back propagated into the neural network in order to update the weight. And finally, what is left for us to do? Well, to implement the asynchronous part. So let me quickly remind what the asynchronous is about. You know that in the previous models that we implemented deep Q-learning or deep convolutional Q-learning, well, we had a single agent interacting in a single environment, and now we're about to kind of upgrade that because we're about to make a class that will allow to have multiple environments simultaneously so that multiple agents can interact with multiple environments as opposed to before where a single agent was interacting with a single environment. Alright, so that's exactly what we're about to implement now in this new code section. So let's create a new code cell, and in fact we'll implement that in the form of a class, okay, which we're going to call env_batch, which is a class that will allow us to handle multiple environments simultaneously in the context of, parallelized reinforcement learning, which is exactly what the A3C algorithm is about. And so, thanks to this env_batch class, well, we will be able to handle simultaneously multiple environments by, for example, facilitating the simultaneous stepping and resetting of multiple environments so that we can use that asynchronous feature of the A3C algorithm much more easily. Alright, so here we go. First, of course, we're going to start with the init method, which will take as input two arguments. First, self for the object, the future batch of environments object that we will create from this env_batch class. And then, as a parameter here, we're just going to enter how many multiple environments we want to manage simultaneously. And so, we're going to add another argument here, which will be exactly this number, and which we'll call n_onps. Okay, and we will give it a default value of 10 so that when we create an instance of the env_batch class, well, by default, we will create and manage 10 environments simultaneously. Perfect, now colon, and here we go. So actually, for this init method, we only have to define one object variable, which will be, of course, our environments, right? Which we'll put in a list, and therefore, this one and only object variable will be the list of these multiple environments. So here we go, let's call it self.onvs. Alright, these are going to be our multiple environments in the list. And well, speaking of the list, we start here with square brackets. And then according to you, how can we create multiple environments in one shot? Well, remember with the makeOnv function, the exact same function that we used before to create our environment. If I scroll back up, here it is. That's the makeOnv function, and we call here the makeOnv function to create our Kung Fu Master Deterministic V0 environment. And now we're going to do exactly the same to create our other multiple environments. We're going to use the makeOnv function through a for loop within a list so that we can do that in one shot. Okay, so how we're going to do that? Well, let's first call the makeOnv function, and then very simply we're going to add this for loop here with a loop variable which we can disregard with an underscore because we won't use it explicitly in that for loop, because indeed we're just going to say in the range from, of course, 0 to the number of environments, which by default is equal to 10. But if, for example, it is 5, well, it will go from 0 to 4. Okay? So there we go. That's the init method. That's the only object variable we have to define. And so now let's create the next method, which will be the reset method, which will allow us to reset these multiple environments at the same time, in order to allow this multiple management of environments. So here we go. Let's call this method reset, which will take as input only one argument, which will be the object itself. So self, and then colon, and here we go. So now, according to you, how can we reset all our self-on's multiple environments at the same time? Well, probably by creating a new list of these initialized states that we can get from our self-on's object containing the different environments. Okay, so that's exactly what we'll do. We're going to create a new variable which we're going to call underscore state, which we will initialize as an empty list with a pair of square brackets. Okay, and now how to populate that list, how to create that list of reset or initialized states for each of the environments in self.onvs. Well, naturally with a for loop, right? Which will loop over the different environments in this self.onvs list of multiple environments. Okay, so here we go. Let's do this. Let's start with for. And here, of course, we will need a loop variable, which will be, of course, the environment among these multiple environments. So let's call this loop variable onv. And of course, each of these environments will be in the self.onvs object variable, which we have here and which contains the multiple environments. So here we go, self.onvs, colon. And now, according to you, what do we do inside this for loop? It only takes one line of code. And that is, of course, to append in that list of initialized states the different reset states in each of these environments in self.onvs. Okay, so we're going to take first our list states, from which we're going to call the append function. And inside this append function, what do we have to do? How can we get the initialized state in each of these environments in self.onvs, the object variable containing the multiple environments? Well, you know this method. It is, of course, the reset method. And so we're going to take our environment first, onv, from which we're going to call this reset method indeed. Here it is. We add some parentheses, and then remember that this reset method actually returns more than the state. If we look again, for example, in our evaluate function, well, as you see, we call the reset method here from our environment, which indeed returns first the state and then some other elements which we disregarded here. But therefore, here, in order to really get the state, which is what we want, right? We want the initialized state. Well, we have to add in square brackets the index 0, because that will return the state and the state only, not the other elements. All right? Perfect. And now finally, let's exit that for loop. We're done with it. We have our initialized states for each of these multiple environments in self.onvs, but we actually want to return this list of initialized states, but in the form of a numpy array, and therefore we're going to finish this reset method with a return, and then we're going to call the numpy library first, from which we're going to call the array function, which will take as input that states list we just created thanks to that for loop. And there you go, my friends. We are now done with the first two methods of this onv batch class. We still have a third one to implement, but we'll do that in the next tutorial because it is a bit longer. So let's recharge a bit in energy, and once you're ready, well, join me in that next tutorial to finish that env batch class with this final method, which will be the step method, allowing to step indeed in multiple environments simultaneously. So I'll see you in that next tutorial, and until then, enjoy AI.